Dr. Brown. In this chapter 8.1, we're going to study inverse sine, inverse cosine, and inverse tangent functions. What we're going to be able to do is, given the value of a trig function, find the angle that it is the trig function of. Some of the things we're going to do in this lesson is find the exact value of an inverse sine function. Basically, we're going to define the inverse sine functions and show you how to calculate it, either using a calculator or using a trig table or the unit circle. Then we're going to use our calculator to find the approximate value of an inverse sine function, and I'd like to point out here that with today's calculators, the values that we pick are very close to the exact value. Then we're going to use the properties of inverse functions to find exact values of a certain composite function. Then we're going to find the inverse function of a trig function, and then solve some equations involving trigonometric functions. Now, I want to remind you that in order for a function f of x to have an inverse, it must pass the horizontal line test. And if you look at the function y equal f of x here, the sine function, notice that if you draw a horizontal line through the function, it intersects the function in several places. It can only have an inverse function only if it passes a horizontal line test. So we must restrict x to allow an inverse function to be defined and calculated. So what we're going to do is we're going to rule out everything outside of minus pi over 2 and plus pi over 2 and restrict the domain to the blue area on this graph. And obviously you can see that now it passes a horizontal line test. So after we have restricted the domain to minus pi over 2 to plus pi over 2, we want to calculate and graph the inverse function of sine of x. So we're going to be looking for what we call the inverse function of x. Now, you probably recall that in order to graph the inverse function of a function, you can just take all the x and y values and exchange x and y, or you can replace y with x and x with y, and then reorient the graph so that y ends up here and x ends up here. And with a little manipulation, you can see, suppose we flip the y-axis so that it's where the x-axis used to be. And notice that the first flip here, the x values are in the minus y direction. So now if we do a mirror image and flip it up, we now have what we call the inverse sine function. What was y is now x, and what was x is now y. And this is what the graph would look like, and this would be y equal inverse sine of x. And notice, as you would expect, the inverse sine of 1 is pi over 2, just as you would expect. The inverse sine of minus 1 is minus pi over 2, and the inverse sine of 0 obviously is 0. And so now we have defined the inverse sine function, and you can take a table of values of the sine function and replace x with y and y with x, and then you would have the values that you need. And here in blue is the inverse sine function, and you might recall that to calculate the inverse sine, or to graph the inverse sine, you can just reflect, to find its inverse, reflect the graph around the line y equal x, and that's what you see here. Now that we know the graph of the inverse function, we can say that y is equal to the inverse function of x. That means that x is equal to the sine of y. So where x is between minus 1 and plus 1, recall now that the sine function can only be between plus and minus 1, and y is restricted to be between minus pi over 2 and plus pi over 2. Now note that the domain of the inverse function is now is the range of the original function, and that the range of the inverse function is the domain of the original function. So to get the domain and range of the inverse function, you just swap the range and domain of the original function. So now let's find the exact values of an inverse sine function. Let's find the exact value of inverse sine of minus 1/2. And so basically what we're asking is, minus 1/2 is the sine of what angle? Now, how are you going to do that? You can use a table, or you can use the unit circle. And know that the angles are restricted between minus pi over 2 and plus pi over 2. So let's just look at the unit circle, and I have taken the unit circle, and for the positive values above 3 pi over 2, I've replaced the angles with the negative values, so that we're looking at minus pi over 2 to plus pi over 2. So we're going to use this side of the unit circle. And so you need to look for a point on the unit circle where the y value is minus 1/2. And notice the y value is minus 1/2 for the angle minus pi over 6. So we can say that the inverse sine of minus 1/2 is minus pi over 6. The other way you can do it is take the table of angles and the sine of the angles between minus pi over 2 and plus pi over 2, and look at minus 1/2, and then go backwards to minus pi over 6 for the angle. So here again, the inverse sine of minus 1/2 is minus pi over 6. And here, laid out for you, is the answer. the inverse sine of minus 1/2 is going to be the angle whose sine is minus 1/2. And as we say, it's minus pi over 6. Now, find an approximate value of an inverse sine function. We're now going to find the inverse sine of 1/3 and the inverse sine of minus 1/4. And we're going to do this on our calculator. Bring up the calculator. And turn on the calculator and make sure we're going to be working in radians, that we're in the radian mode. We're in the radian mode. So now do second sine, which is the inverse sine of 1/3. Hit enter, and you get, round it off to the nearest hundredths, 0.34. Now to calculate inverse sine of minus 1/4, put minus 1/4. Hit enter, and you get minus 0.25 to the nearest hundredth. Now we can use the properties of the inverse functions to find exact values of certain composite functions. Notice, fundamentally, if you take the inverse function of f of x itself, remember you always get your x back, and if you take the function of the inverse function of x, you get your x back. So the inverse sine of x gives you your x back. The sine of the inverse sine function, you get your x back. Notice that for the inverse sine, the angle has to be between minus pi over 2 and plus pi over 2. And the value of the sine, obviously, is going to be restricted from minus 1 to plus 1, inclusive. So now we're going to use the properties of the inverse sine function to calculate some composite functions. Here is the inverse sine of pi over 8. Notice that pi over 8 is in the domain, is in the range of the inverse sine function. So the inverse sine of pi over 8 is just simply going to be getting your x back, which is pi over 8. Now notice, for inverse sine of 5 pi over 8, 5 pi over 8 is out of the range of minus pi over 2 to plus pi over 2. So we're going to have to look at 5 pi over 8. And what I would do without this diagram here is draw the diagram and look at this angle 5 pi over 8 and realize that this angle over here would be 3 pi over 8, which is just pi minus 5 pi over 8. And notice, in order to find an angle that's between minus pi over 2 and plus pi over 2 that has the same value of sine, if we have A and B here, the angle that has the same value of sine would be minus A and B. And that means that this angle would be 3 pi over 8. So now we can say the inverse sine of 5 pi over 8 is going to be the inverse sine of 3 pi over 8, because the sine of 3 pi over 8 is the same as the sine of 5 pi over 8. And therefore, inverse sine of 3 pi over 8 is 3 pi over 8. Now, we're going to do the inverse cosine function. Notice that the cosine function itself does not pass a horizontal line test. So in this particular instance, we restrict the domain of x to be between 0 and pi. Excuse me. And so if you look at the blue function here, it passes the horizontal line test if you just look at it between 0 and pi. And then imagine taking the inverse function and replacing y with x and x with y. Doing this restriction, this would become y, and this would become x, and flip the axis. And now we have the blue function here will be our inverse cosine function. So now in the unit circle, for instance, we would go between 0 and pi and look at values on the unit circle between 0 and pi and ignore the values down here. So now the definition of inverse cosine function means that if y is equal to inverse cosine of x, then x is equal to cosine of y, where x can be between -1 and +1 inclusive, and that y is between 0 and pi. So let's find the exact value of an inverse cosine function, in particular inverse cosine of minus the square root of 2 over 2. You can do this two ways. You can look at the unit circle and look for where the cosine of an angle is minus the square root of 2 over 2. And of course that's the x value. And so notice x is minus square root of 2 over 2 for the angle 3 pi over 4. So the inverse cosine of minus the square root of 2 over 2 is 3 pi over 4. You can also develop a table of theta and cosine of theta, and then look for minus the square root of 2 over 2 for the cosine function, and find out that angle is equal to 3 pi over 4. Now, looking at how you would use composite functions, recall again that the inverse of the function itself, you get your x back. So the inverse cosine of cosine x is equal to x. The cosine of the inverse function is also equal to x. These are just properties of an inverse function where the function is equal to cosine of x. Now, we're going to calculate using the properties of inverse functions to find the exact values of these composite functions. Notice that for the angle pi over 12, that is within the range, the restricted range of the cosine function, because it's between 0 and pi over 0 and pi. So the inverse cosine of cosine of pi over 2 will be pi over 12. Notice that the cosine function is between minus 1 and plus 1. So cosine of the inverse cosine function is going to be minus 0.4. But notice that for number C, the angle is not between 0 and pi, but we need to find an angle that's between 0 and pi who has a cosine function the same as a cosine of minus 2 pi over 3. So notice that looking at the negative values of theta, here is 2 pi over 3, here is minus 2 pi over 3. And we want to find an angle whose cosine is the same as minus 2 pi over 3, and its cosine value is minus 1/2. But notice that 2 pi over 3 and minus 2 pi over 3 have the same cosine values. So cosine of minus 2 pi over 3 is equal to, inverse cosine of minus 2 pi over 3 would be the same as inverse cosine of 2 pi over 3, which is 2 pi over 3. Now finally, look back at the last one. We're trying to find an angle whose cosine is pi, which is about 3.14. Note that cosine has to be between 1 and minus 1. So inverse cosine of pi is undefined. So our conclusion is that cosine of inverse cosine of pi is also undefined. Now, the last inverse function we're going to look at is a tangent function. And you recall that the tangent function is periodic with a period of pi. So obviously it doesn't pass the horizontal line test, but if we restrict it to minus pi over 2 to plus pi over 2, we can define the inverse tan function. So here is the tangent function that's restricted for x between minus pi over 2 and plus pi over 2. And we can imagine now that if we replace x by y and y by x, and flip the graph so that y is pointed in the right direction, we get the blue function here, inverse tangent of function. And notice its y value will approach pi over 2, but never touch it. And the x value will go between minus infinity and plus infinity. And for the definition of the inverse tangent function, y equal inverse tangent of x means that x is equal to tangent of y. Notice that x can be between minus infinity and plus infinity, not including, obviously, and that y is between minus pi over 2 and plus pi over 2. Now, find the exact values of an inverse tangent function. Let's find the exact values of inverse tangent of 1. Inverse tangent of 1 means you want to find a point on the unit circle where y over x is equal to 1, because that's the tangent of theta, and that happens to be pi over 4, because notice for the angle pi over 4, x and y are both the square root of 2 over 2. You can also look at the table. If you did a table of the angle theta between minus pi over 2 and plus pi over 2, you will find that if you find a tangent value of 1, its corresponding angle is pi over 4. Now, to find inverse tangent of minus the square root of 3, I have a unit circle here that's set up for angles between minus pi over 2 and plus pi over 2, and look for y over x equal to minus the square root of 3. And notice that y over x equal minus the square root of 3 is for theta equals minus pi over 3. So, as this indicates here, looking at table 3, looking at minus pi over 3, its tangent function is minus the square root of 3. And we saw that also looking at the unit circle where theta is equal to minus pi over 3. Now we want to find the inverse function of a trigonometric function that might be given. We need to recall how to calculate an inverse function. Remember, what you do is you write y equal f of x, then you interchange x and y. In other words, write x equal f of y. Everywhere you see a y, put an x. Everywhere you see an x, put a y. Then solve for y, and the y that you solve for will be the inverse function of x. Okay, let's look at the function here, f of x equal 2 sine of x minus 1. And notice they've restricted x to be between minus pi over 2 and plus pi over 2. They restricted that because otherwise the function would not have an inverse function. So let's look first at the domain of f, and it's defined between pi over 2 and minus pi over 2. Notice then that the range of f, if sine of x maximum value is 1, then x can have a maximum value of 1, because that's 2 sine of pi over 2 minus 1. That would be the maximum value, equal 2 minus 1 equal 1. And then the minimum value of f would be when the sine of x is minus 1, and that is minus 3. So we expect that we know that the domain of f is x between minus pi over 2 and plus pi over 2, and the range is minus 3 to plus 1. Now we're going to calculate the inverse function. Write down the function y equal 2 sine of x minus 1, interchange x and y, and we get x equal 2 sine of y minus 1. Solve for y, and adding 1 to both sides, we get x plus 1 equal 2 sine of y. Solving for sine of y, we get sine of y is equal to x plus 1 over 2. So y then is equal to the inverse sine of x plus 1 over 2. So the inverse function of x is equal to inverse sine of x plus 1 over 2. Now, the domain and range of the inverse function is going to be just taking the domain and range of the original function and interchanging them. So remember, the original function range was minus 3 to 1. So the domain of the inverse function is minus 3 to 1. And the range of the inverse function is the domain of the original function, which was minus pi over 2 to plus pi over 2. Now we're going to do very quickly an example of showing how to solve equations involving inverse functions. Basically, if you've got an inverse function and you want to solve for a value of x, you need to take the inverse and to undo the function. So let's say we want to solve this equation. If 3 inverse sine of x equals pi, then we know that inverse sine of x equals pi over 3. So now, to solve for x, we take sine of both sides, is equal to sine of pi over 3. Remember, you do the same thing to both sides of the equation to keep things equal. Now the sine of inverse sine of x is equal to x, so x is equal to sine of pi over 3. which I believe is the square root of 3 over 2. Yes, it's the square root of 3 over 2. So you'll find homework problems very similar to these. I'd advise you to work them, and this is the lesson for today.